Ready? Okay, this Frankendrive. I got the wristband on. It's Bluetooth up. The battery is just stuck on top. So we're synced up. Oops, I accidentally shut it off. It just rained this morning, so you can see it works just fine. The full flow. No noticeable change in power. So I'm going to go ahead and hide that board underneath, and that's the usual motion to stop it. So I'm going to go ahead and hide that battery, put the radio on top, rewire everything, and put it back together. So here's the beginning of Frankenstein 1, and what you're looking at here is a standard hoverboard battery that's available on Amazon, eBay, many other places. Watch these things, there's two different sizes. This is the 70 millimeter wide. This port is where the RS-232 plug from the BMS plugs into, and we're gonna try and see what it does. And the worst thing that happens is I hurt this, and we'll have to go to the drive. This, once again, is an MX2 board instead of the MX2 Plus. I have one of each. So this was my original, and I bought an MX2 Plus for parts. It turned out the BMS inside the battery was had the same issues that mine did originally. So didn't do me any good. I spent almost $500, over $500 on parts that were no good. Okay, here's the Frankenstein setup just for test. So I got the battery with the connector cut off it. The green wire is actually red. It's a little bit tough to see, but what I did was I wired this into the charge. Goes to the negative side. The power goes to the negative side. And then the green, which is going to be positive, goes to both reds. I also reconnected everything on the board. So if we go over this again, this is the on-off switch. This is power from the battery. These are the 4 LEDs up front. This is the charge communication with the main board. This is the Hall sensor from the motor with an extra conductor. That white conductor is the speed conductor. And then the power going to the motor, all 3 phases. So in theory, the way this thing should work is the MX2 takes a set point from the current speed of the motor, and then when it detects a push, it uses that for the cruise. So this would be like a regular brushless DC drive with a cruise. The cruise is turned on and off by the Bluetooth bracelet. So pretty simple. Takes a set point from there, then sets the cruise. The trouble is I don't know what's on this board, because obviously the people that build it are not going to give me information on a medical device and how to modify it. And I talked to eBack, the battery people, and they won't give anything up on the battery or the BMS or what the RS-232 connection does. So we're about to find out with a smoke test here. Okay, so we got Frankenstein over on this side. Batteries up here. This is the last connection. We should get a little spark here as we charge the caps. And I'm going to nut this thing up. So now we have power run to the unit. I checked the voltage on this, 39.6. So it should be good enough to show charge, but low enough that it does need to be charged. So we'll be able to check this stuff out. So if we come over here and turn the power on, I have no idea what it's going to do. It's showing full charge. So the next thing we need to do is gonna simulate a run. Ready? Okay, this Frankendrive. I got the wristband on. It's Bluetooth up. The battery is just stuck on top. So we're synced up. Oops, I accidentally shut it off. It just rained this morning, so you can see it. It works just fine with a full flow. No noticeable change in power. Okay, so that's Frankendrive, and what I'm going to do is make sure it goes through a full charge and the charger shuts off and is compatible with the BMS. And then I'm going to go bury that radio just underneath where the battery is currently at and put the battery in upside down on the bottom cap. So we're actually reverse the stuff. I'll show you the guts inside, but Frankendrive. We got Frankendrive, and it's plugged in, fully charged. The automatic charger shut off, and the battery is fully happy. So I think I'm going to go ahead and cut those guts on the inside rather than pay $1,400 for a battery. Hate to do this, but I didn't find any way around it. So what I'm doing is putting foam in the front to keep the battery off of the wires right here on the charge circuit, because when we drop this in and we start pushing it down, it's going to get very, very close. Also, there's no room for the box, just the difference between the ends here. It fits very tight in the lower compartment, so I had to cut the box that used to contain the battery, and I'll mount the computer on this, mount that in the side, right in the slot here, and I'm going to solder the wires on this one just so I can redo it later with correct plugs. I don't happen to have them, so I'm going to do it later. So just about ready to put the lid on Frankenstein here. That board that box that I showed you that I cut, the board's mounted back on it. It's mounted with two screws and the little rubber grommets down at the bottom. I soldered onto this, soldered both ends onto here, plugged into the charge there and into the power over on this side. Believe it or not, the battery does fit if you look on the lid over here. This is actually the big side where the computer ends up. So there's room for the computer on that side, and it is absolutely wall-to-wall battery. It just barely clears the front. Okay, it looks remarkably stock when it's put back together. That's with the battery in it, all buttoned up. The O-ring did seal, and it seems to work fine. We'll turn this on. We got the blue blinking. I took it out of Learn, and it works just like normal. If you're wondering what it's for, it's so I don't have to push. And notice I'm steering just by pulling. And if we want to go faster, we can push faster. Takes the new set point. That's simple. That's the stop motion.